All right, let's talk about one of the boldest claims I've ever seen come from a new tech project. We're going to unpack the carbon blueprint for a system called Knowledge 3D, or K3D for short, and it makes some truly mind-boggling projections.
So here's the headline number. The project is forecasting a potential cumulative saving of 12.826 gigatons of CO2 equivalent over the next 10 years. And that word equivalent is key. It means we're talking about all greenhouse gases, not just carbon dioxide. That's gigatons with a G, a number so massive it's almost hard to wrap your head around.
So, to really get a feel for that number, let's just imagine for a second. What would it actually mean for the planet if a single shift in how we write software could deliver on a promise that huge?
Well, for starters, it would mean we could potentially wipe out almost 7% of total global emissions every single year by 2035. This isn't just a tiny tweak or a minor optimization. We're talking about a serious slice of the entire world's carbon footprint. Here's another way to think about it. An impact on that scale is like taking 550 million cars off the road. And not just for a year, but permanently. The scale is just massive. So you have to ask the question, right? Where on earth are all these savings supposed to come from?
So let's do that. Let's deconstruct these savings. The whole projection really boils down to 4 key areas of impact. Now, what's fascinating here is how this is all distributed. You see some familiar categories, right? Video streaming, data centers. But look at them. They're totally dwarfed by that enormous blue slice for robotics. That robotics piece, it acts as a massive multiplier for the whole thing.
And this table puts the hard numbers to that chart. You can see it clear as day. Yeah, there are savings across the board. But robotics is the undisputed heavyweight champion here. It's forecast to save over 2 gigatons a year by 2035. That's more than 10 times the other 3 categories put together. It's a total game changer.
So what's the secret sauce for robotics? Well, the K3D architecture is designed to power a completely new kind of robot, one that's hyper-efficient. These aren't the robots we see today that are constantly phoning home to some power-guzzling cloud-based AI. Nope. The idea is they run their entire brain right on board with incredible efficiency. This brings us to the really interesting part. What is the technology that could make this happen? The forecast itself uses what's called a sigmoid adoption curve model, which is, a pretty standard way to predict how fast a new tech might spread. But the whole thing is built on 4 foundational principles working in concert.
These are the 4 pillars, the interconnected catalysts that aim to completely rewrite the rules of computational efficiency. So let's take them one by one.
Okay, first up, procedural compression. The idea here is actually pretty simple, but it's incredibly powerful. Instead of storing a massive file, like a digital painting with millions of pixels, you just store a tiny little program, the recipe, that paints it for you perfectly every time you need to see it. That shift from storing data to generating it, that's the key. And this really is the fundamental change. We're moving away from storing heavy static data to generating it procedurally whenever we need it. Almost all our modern media is pixel-based. K3D's argument is that this old way of doing things is the real source of our digital world's massive inefficiency. The second catalyst is called Matryoshka Adaptive Dimensions, and it's inspired by those Russian nesting dolls. The system only uses the computational size it absolutely needs for any given task. So if it's just rendering some simple text, it uses a tiny computational model. But if it's rendering a photorealistic 4K scene, it scales way up. It's all about not wasting a ton of energy on the simple stuff.
Number 3 is this really clever trick called ternary sparse updates. Instead of forcing the GPU to re-render the entire screen every single frame, the system uses a special logic. The most important part is a state that basically tells the GPU, hey, nothing changed in this spot, just skip it. Think about a video call where only your face is moving. This could save up to 70% of the energy.
And finally, the fourth catalyst is sovereignty. The entire architecture is built to run locally, right on your device's GPU. By cutting out the constant back and forth to the cloud, it aims to max out performance and slash the energy that gets wasted just sending data around.
So when you combine these 4 technologies, the projection isn't just about saving a bit of energy here and there. It's about creating a whole new blueprint for how we can build a digital world that's actually sustainable. This system really reimagines how we interact with information. It's not just about more efficient video streaming or AI. It's about creating a shared,
understandable and computationally elegant 3D space where humans and AI can truly collaborate.
And let's bring it all back to that annual savings number. That 2.565 gigatons projected to be saved every year by 2035, that could actually account for about 10% of the entire reduction target set by the Paris Agreement. A single technology contributing 1/10 of the global goal. It's just a staggering thought.
And that really leaves us with a powerful final question, doesn't it? We always think about electric cars, solar panels, planting trees, and those things are absolutely critical. But what if one of our most powerful tools in the fight against climate change isn't physical at all, but is actually a fundamental change in the code that runs our world?
The project's vision kind of reframes our entire digital world with this quote. It suggests a more integrated, a more efficient, and a more embodied future. It's a fascinating, and you have to admit, an incredibly ambitious idea to think about.